The German road construction industry has steadily evolved over the centuries to a well-optimized, innovative, efficient, and convenient roadway construction industry. They can, from the systematic construction of gravel and cobblestone roads up to the modern and more complex asphalt pavements for highways, streets, and other roads in the country, have always aimed at improving the infrastructures while at the same time protecting the lives and properties of all individuals. In what way has Germany embraced innovation in the construction of roads? And what is the future of road construction in an environment that is constantly changing due to technology? Also, what are the best constructions made in the least amount of time? Join us as we share with you some of the amazing features that Germany has integrated in road construction. The evolution of German road construction. German road construction history dates back centuries, from the early simple tracks to a complex network of roads in the modern world. This evolution is thus inherently linked to the development of transportation technology, social requirements, and the German desire to construct the best roads available. During the early days of Europe, especially the regions which we now know as Germany, had nothing more than pathways made of soil. These paths would often become inaccessible, especially during rainy seasons, as they were nothing but muddy, dangerous marshes to travelers. However, noticeable changes to the construction of roads emerged during the Roman Empire, which marked another revolution of structured road systems that formed the basis for other changes. From the time of the Romans, the principles of road construction were advanced to an extent that can only be described as revolutionary. They used gravel and cobblestone for road construction and used layering structures to ensure that the constructed pathways could not be penetrated by weather elements. Through the use of the tiered layers, commonly referred to as macadam construction, coupled with drainage systems, the roads would last for longevity. These techniques were carried on for centuries, though the technology of transportation was evolving throughout the process of road construction. Jump forward to the beginning of the 18th century, and governments in Europe, and indeed Germany, came to realize the need for better roads that could last longer and cope with the increased traffic following the advent of motor vehicles. While gravel and cobblestone roads provided longevity, the rough and dusty surfaces presented considerable risks to driving fast cars on the roads. With the increase in the speed of vehicles and their prevalence, safety emerged as a critical factor that required more advancements. Germany, being part of what was previously considered the European Empire, experienced an extremely rapid infrastructural development during this period. The country started using tar bitumen and later asphalt in constructing roads, which gave a smoother and more sustainable surface to the roads. They contributed in eradicating the hitches of dust accompanying gravel roads, hence enhancing safety and functionality of the road sector. On the other hand, the construction of asphalt roads marked the beginning of modern construction of roads. The invention of roads made from bitumen also solved the problem of surface irregularities and gave engineers an opportunity to construct roads with better qualities that could accommodate traffic and large vehicles. Furthermore, asphalt offered a certain flexibility in terms of the flow and curvature in the road networks, particularly as it was important to sustain speed as well as safety in the newly innovated motorized society. The transition from cobblestone roads to the Autobahn is a clear indication of the country's advancements in road construction. Nevertheless, it was not an overnight change that occurred in this area. It became a gradual process with the introduction of new technologies, materials, and methods to increase the capacity of transport for the modern world. But what technological advancements enabled Germany to continue enhancing its road-building processes? New technologies in the construction industry of roads in Germany. Germany's road construction industry has been very active, always looking for a way to enhance efficiency, safety, and environmental sustainability. Over the decade, there have been significant improvements in the technological aspects of constructing, maintaining, and repairing the roads, which have helped, among others, Germany to not only construct good quality asphalt roads, but also construct them without affecting the traffic. Another interesting fact is the application of the latest surveying technology in German road construction. Before any construction project is commenced, engineers make use of Global Positioning System (GPS) and the Global Navigation Satellite Systems (GNSS) to survey the construction site and get measurements. Civil engineers can produce very precise designs with the help of programs like AutoCAD, based on the geographical features and traffic requirements of the region. This level of precision reduces the measures of variability and makes it possible to construct roads to suit the requirements of their location. The use of innovative tools that enable acquiring accurate geographical information has greatly enhanced the pace at which road designs are made, since engineers can change their plans as they go along and thus save considerable time. This technology is also important when constructing new roads to ensure that the road construction is well drained in case of rains to avoid early degradation of the roads and thus protecting the quality of the asphalt surface. Once the design phase is complete, the next major innovation in road construction comes into play: the removal of worn-out road materials to be recycled. Sustainability is important in Germany. The same applies to construction of roads. The old asphalt that is usually used in the construction of existing roads is not just dumped whenever new roads are to be constructed. It is therefore taken, but taken with caution, and then crushed before being used again in other roads. This practice also helps to minimize the effects of road construction in the environment due to less exploitation of raw materials such as crude oil. The use of recycled asphalt does not compromise on quality, since it is made up of the same coarse aggregate, fine aggregate, and asphalt cement as that used in the production of the full asphalt. Through the use of these materials in its road construction projects, Germany has enhanced the sustainability of its projects by reducing the amount of carbon emissions, conserving natural resources without compromising the quality and durability of the roads. The utilization of German technology has also advanced in the construction of actual asphalt roads itself. In the past, road construction work usually entailed road closure or road diversions, which may last for several days or even weeks. There has been some development of new techniques that enable resurfacing and repairing of roads without complete closure of the road. Of these, one of the most notable is the employment of equipment that allows road construction to be done in a manner that does not completely close off the road by having at least one lane available. This technique entails the process of removing portions of the road while other parts are left for the drivers to use. With the section closed, it is possible to overlay new material, compact, and grade it to ensure a smooth surface. All these being done while traffic is still passing in the other lanes. The equipment employed on these projects has been described as some of the most innovative, as it can easily place asphalt layers without any interruption. Furthermore, the asphalt is compacted once it has been spread on the road, which also means that the road will be ready for use very soon. This approach is much shorter and faster than the traditional construction project, and it has less effect on the drivers and businesses alike. But how does Germany make sure that these asphalt roads are long-lasting and can withstand extreme traffic conditions? Preparation and placement of the asphalt subbase. The subbase is one of the most crucial components in the construction of asphalt pavement. Although this process is not evident to the drivers, it is important for the stability and durability of the road surface. Engineers in Germany pay a lot of attention to preparing and placing of the subbase, since it acts as the base for the asphalt pavements. The subbase serves two primary functions, as it also prevents frost heave, which is the up movement of the road due to the freezing and thawing of the ground underneath the road, and it offers a good bearing capacity to support both the asphalt pavement and the expected traffic load. It can be crushed rocks, recycled asphalt, or even the concrete from the previous construction projects, depending on the need of the project. The preparation of the subbase is a very delicate affair, which requires the use of road graders and other construction equipment so as to achieve the kind of surface that is required, which is a smooth and level surface. Washboard or potholes are likely to be observed in the subbase, which must be addressed prior to the installation of asphalt. Also, engineers pay attention to the grade, which is the steepness of the road, as it affects the safety of drivers, especially those who are ferrying bulky loads. After the subbase has been constructed and compacted to the required standards, the next step is to make proper transition between the new asphalt layer and the existing pavement, parking lots, or curbs. It's at this point that butt joints come into the picture. Butt joints are essentially the interface between the new pavement and the older asphalt or concrete pavement, and these joints need to be blended as smoothly as possible to provide good ride quality. Besides butt joints, engineers also consider curbing while designing a structure because of its role in the management of water at some point when it rains a lot. The curbing is usually placed parallel to the pavement, and this offers a finished look to the particular road, and at the same time it serves as a barrier to prevent erosion and a guideline for cars. Following the preparation of the subbase and placing of butt joints and curbing, the subsequent step in the construction of a road is the laying of base course. The base course is an aggregate base or a binder course which provides the foundation for the asphalt pavement. It is placed and spread evenly on the subbase, then compacted to the highest level of strength and stability. To the general stability of the road, it is important that the base course be compacted. The engineers also employ some equipment to ensure that the material achieves at least 95% relative compaction so that it can support the weight of the heavy equipment and refrain from deforming. This step is crucial in the establishment of a proper subgrade base on which the asphalt pavement will be constructed. After the placement of the base course, the wearing course, also referred to as the surface course, which is the outermost layer of the road, is put in. This layer is intended for handling the traffic loads and also for withstanding the wear and tear, which might be as a result of factors such as rain, snow, and temperature differences. What are some of the famous materials and approaches used in the construction of modern roads? Ancient techniques of road building. Road construction was one of the significant factors to the development and sustenance of different civilizations in the ancient world. Transportation through roads enabled people to interact and also transport goods, culture, and ideas from one place to another. The Roman Empire, Mesopotamia, the Indian subcontinent are among the earliest civilizations to develop road construction techniques that would shape history. Roads constructed by the Romans were very effective and always played a major role in determining the outcome of a battle. The Romans constructed an elaborate system of highways, mainly for military usage but also commercial and social. Roman engineers aimed at choosing the right paths for the construction of the roads, which linked the large cities and towns. These roads were constructed in sections with the first layer comprising large stones and the second layer being gravel and sand, while the last layer was cobblestone. The upper layer provided a smooth, hard, and slightly curved surface to facilitate the runoff of rainwater at the edges of the structure. These roads were constructed to be durable and to be able to handle traffic and weather conditions, and many of these roads are even visible today as great specimens of great engineers. Likewise, in Mesopotamia, road construction was an integral part of city planning and design. City-states of Mesopotamia developed elaborate road infrastructure to enable connectivity of cities, villages, and commerce centers. These roads helped in transportation of items like grain, textiles, pottery, and also helped in maintaining communication between cities. While these roads were not as strong as the Roman roads, they were essential for the economic development of the region. Roads were made of mud bricks, compacted earth, or wooden planks, but where flooding was likely to occur, the engineers would overlay the roads with gravel or stones. Road construction in the Indian subcontinent received a new dimension during the Mauryan Empire that was in between 322 and 185 BCE. Mauryan kings constructed many roads, some of which are the Grand Trunk Road, which connected from the east of Ganges Delta to the western frontiers of Hindu Kush. These roads were used for transport and communication within the large empire throughout the time of the Roman Empire. Mauryan engineers used stones, gravels, and wood to ensure that the roads constructed were strong enough to endure the climatic conditions in the subcontinent. Through the construction of roads, the Mauryan Empire laid the foundation of India as one of the primary trade and commercial hubs in the ancient world. With the advancement of civilization, there was also advancement in the construction of roads. During the medieval age, remarkable progress was made in the construction of roads as societies focused on enhancing their transport system. In Europe, wooden bridges and stone-paved roads were utilized in the construction of the roads. These structures helped people to cross rivers and marshes and thus save time that would have been used while moving from one city to another. The Chinese were seen as pioneers of ancient road construction, where they constructed the Silk Road during the time of the Han Dynasty, which extended from 206 BCE to 220 CE. It was a system of canals which linked China with the Middle East and Europe, helping to transport goods including silk, spices, and metals. The evolutionary change from the ancient methods of road construction to the modern techniques was one of the defining moments in the evolution of infrastructure growth. The appearance of new materials and construction possibilities also helped to improve the speed, efficiency, and stability of road construction. Another significant advancement in the construction of roads in the modern world was the emergence of asphalt and concrete as materials used in construction of roads. Asphalt is a combination of aggregates that include sand, gravel, crushed stone, and bitumen, which has its origin in the 19th century for purposes of paving streets. Soon, the material was widely appreciated by society due to its such advantageous characteristics as the durability, elasticity, and non-requirement in regular treatment. Asphalt roads give a flat surface that can handle traffic congestion and any acts of nature that may affect roads. Also, the material is easy to lay, hence construction projects that require asphalt will take less time to be accomplished, and this will not take time off many weeks or months, hence traffic will not be much affected. Concrete, which is another primary component in the construction of roads in the present era, has its own benefits. Concrete roads are designed through cement, water, and aggregates, and are long-lasting structures that do not require frequent repairs or construction for many years. Asphalt is comparatively more flexible than concrete, and this makes concrete to be more resistant to deformation as a result of heavy loads. However, it can be more difficult to use because it takes longer to cure and requires more skill in construction. Nevertheless, concrete is adopted in the construction of highways, bridges, and other large-scale structures that require high durability and service life. Another major revolution in the construction of roads was the macadam construction, which was done by Scottish engineer John Loudon Macadam in the early 19th century. This method entailed placing a layer of gravel and stones and then other stones and gravel and compacting to ensure a level and firm surface. Macadam roads were far better than the dirt roads that were used in the past because they could bear the weather and enormous traffic loads. This technique was the foundation of modern road construction and is used today with slight changes. Another major technique that revolutionized road construction was the use of precast sections, which greatly enabled construction of roads and highways. This involves building segments of the road separately, then transporting them to the actual site and fixing them. These sections are created from reinforced concrete or asphalt, and are relatively simple to transport and lay down on the road network. Besides new materials and technologies, improvement of machinery has also been greatly contributed to the present construction of roads. Equipment such as asphalt paver, concrete mixer, and compaction equipment have mechanized most of the work to be done manually, hence greatly enhancing the speed at which construction is done. For instance, the Caterpillar AP 555F mobile track paver is a modern machine used to pave the road with asphalt and is well suited for large jobs since it can pave a width of up to 18 feet at one time. Some of the features that have been incorporated in the AP 555F include the Caterpillar Pave Smart system that provides accurate and uniform paving that does not require frequent interference with the process, improving on the quality of the road surface to be made. This simply means that as more technologies are being developed, the quality of work done and the short time taken to build roads, for instance, will only get better. What are some of the more notable feats of the current road construction works? Some new record achievements in construction of road. The recent years have witnessed a tremendous advancement of road construction, with some projects being constructed in relatively shorter periods of time than ever. Perhaps one of the most striking examples of such rates is the construction of a 57-story skyscraper by a Chinese construction company in 2015, which took only 19 working days. This accomplishment was made through the application of prefabricated building modules that were constructed in 2 construction phases, interrupted only by adverse weather conditions. Within a few weeks, the time-lapse video of this project became quite popular and demonstrated the capabilities of modern technologies in construction. Likewise, in the year 2018, another video was viewed millions of times when a railway station in China was upgraded and a new railway track was built in just 9 hours. This project was carried out by 23 excavators and 1,500 workers, who had to work simultaneously to ensure the completion of the upgrade without closing down the station. In this way, the decision to use prefabricated sections and the efficient work of several teams made it possible to complete the work in record time. This shows how the current construction technology can minimize the duration it takes to complete infrastructure projects through pre-construction and use of sophisticated equipment. The Ghaziabad-Aligarh Expressway project in India broke the record for constructing the longest continuous stretch of asphalt in a single operation in 2023. In the course of 100 hours of work, the workers have laid down 112.5 lane kilometers of bituminous concrete, which required approximately 41,382 tons of asphalt. This huge task was accomplished by employing advanced equipment, including high production capacity asphalt paver and asphalt plant, that supplied this material on the construction continuously. This could only have been made possible by the enhanced construction technologies that allowed the laying of such an expansive surface in a relatively short span of time. One more impressive accomplishment in recent years is the construction of the T30 hotel tower in Changsha, China. This 30-story hotel was constructed by Broad Sustainable Building Company, and it only took them 15 days or 360 hours to complete. The hotel was built using steel frames that had to be assembled on site, and this had helped to cut on the construction time. Apart from fast construction, the T30 hotel tower is also very strong, as it is being built to survive a 9-magnitude earthquake. These examples demonstrate the tremendous strides made in the construction of roads and buildings, making them stronger, faster, and much more efficient than before. Construction of roads in the modern world has been made faster due to the assistance of some sophisticated equipment. These include the asphalt paver and the cold milling machine. These have been very influential in construction of roads and maintenance of the same. Like many other machine tools, one of the most significant machines in this aspect is the Caterpillar AP 555F mobile track paver. This equipment is used to pave roads with asphalt within a short time, with the maximum width of the paved surface being 18 feet. It was powered by a Caterpillar C7. One ACERT engine, the AP 555F, provides about 130 horsepower, which provides sufficient power to manage large projects. Moreover, the AP 555F comes with state-of-the-art screed technologies that enable the operator to determine the thickness and smoothness of the asphalt. This makes it possible to achieve a perfect surface finish to the desired specifications of the project being worked on. Its hopper can contain up to 10 tons of material, meaning that the machine will not have to be refilled constantly, and this will increase the amount of work that is done. Furthermore, the Caterpillar Pave Smart system has a feature of automatic control of grade and slope, thus making paving accurate and constant. Another great machine that is used in the construction of roads is the Power Kerber 5700C, which is an asphalt paver that is best suited for curbing narrow streets and wide highways, with a paving width up to 4 meters in width with a depth of up to 300 mm. The Power Kerber 5700C comes in handy, especially in heavy resurfacing activities. The large hopper of the machine, with the carrying capacity of about 12 tons of cement, means that the machine can work for a long time without being replenished with the raw material, increasing efficiency. Cold milling machines, including Wirtgen W210 Phi, are critical for road repair work. These are machines intended for the removal of asphalt and concrete surfaces, and since they are very effective in this particular, they are perfect for major road repair projects. The W210 Phi comes equipped with a powerful Deutz TCD 2013 L06 engine that produces 563 horsepower, making it ideal for milling tough applications. The milling width of the machine can go up to 7.8 feet in a single pass, which makes it ideal to be used in narrow roads, as well as the wide highways given that it can pave. The Wirtgen Level Pro Plus system offers centralized control for the grade and slope, and the milling depth is optimized for a perfect surface. It also incorporates a high-capacity conveyor system that handles material removal, hence speeding up the milling process to fasten delivery on milling projects. It can therefore be said that as the machinery of construction continues to advance, the construction of roads will be quicker and more efficient in the future. However, in the context of the present and future of road construction, what is the place of sustainability? Road construction for sustainable future. The importance of road infrastructure cannot be overemphasized, especially with the increase in urbanization across the globe and the expansion of economies. Nevertheless, the conventional construction techniques of roads, despite improvements made in the past few years, have their drawbacks in terms of environmental impacts, cost, and long-term performance. Today, the construction industry is at the crossroads, with new technologies and innovative materials ready to revolutionize the road construction sector. While effective, traditional asphalt and concrete have severe environmental impacts. Asphalt is obtained from petroleum and is therefore non-renewable and causes emissions of greenhouse gases during its processing. Concrete production, for instance, contributes about 8% to the overall global emissions of CO2, mainly because of the energy used in cement production. Knowing these challenges, researchers and engineers are working on the use of other materials that are strong and at the same time eco-friendly. It has been proved that recycled plastic roads can be implemented in countries like India, Netherlands, and the UK. In these projects, the waste plastic is blended with the bitumen to produce a stiffer and stronger asphalt. Studies have also indicated that using plastic in the production of asphalt increases the durability of the surface in terms of resistance to potholes, lowers the maintenance expenses, and increases the durability of the road. Also, the use of plastic in construction of roads has benefits of reducing pollution, since it helps in managing wastes that could otherwise end up in polluting the environment through landfills. Another such material that is being considered is rubberized asphalt, which is made of used rubber from the tires and incorporated into the asphalt. Annually, millions of tires are dumped, which end up as landfill waste and potential sources of pollution. In incorporation of ground-up tires into road construction, rubberized asphalt not only deals with the issue of waste disposal, but also enhances the efficiency of the road. Asphalt is the most renowned material in road construction, but concrete has become popular because of its strength, and it is known to have a negative environmental impact since cement production emits carbon. To minimize this effect, researchers are coming up with geopolymers as more environmentally friendly than Portland cement. Geopolymers are made from industrial waste like fly ash, slag, kaolin, which can be used to replace cement in concrete and combined coarse aggregates. The use of geopolymer concrete has the following advantages over the normal concrete. It is less carbon, chemically corrosion, and heat resistant compared to other conventional materials. It is also very strong and can therefore be used to construct long-lasting roads for the people. Though in the developmental stage, the use of geopolymer concrete in road construction may significantly reduce the impact on the environment in the future. One of the most promising trends in road construction materials is the creation of smart concrete and asphalt that can heal themselves. They are made to self-heal when small cracks or damages occur, allowing the road to last longer without frequent maintenance. Self-healing materials are especially suitable for areas of extreme weather conditions or high traffic, where roads tend to wear out very fast. Some of the most revolutionary strategies for smart roads include solar roads, in which photovoltaic materials are incorporated into the road surface to produce electricity. Solar roads have the opportunity to take advantage of the great expanse of highways and streets by converting it into renewable energy for the use of streetlights, electric car charging stations, homes, and businesses. More elaborate ideas, such as the Solar Roadways project in the United States or the Wattway project in France, brought the concept of solar roads on the world stage. These projects entail placing durable, clear glass covers on roads. The structures admit sunlight to reach photovoltaic cells beneath. The produced electricity can be supplied to the grid or used locally to supply the roadside facilities. Despite the current state of solar road technology, it has the capability of greatly decreasing carbon footprints and making transportation structures more environmentally friendly. However, one has to consider how the panels can be made strong enough to support the weight of heavy vehicles, and also how the cost of installation is feasible on a large scale. What do you think of the way and future of road constructions? Let us know your thoughts in the comment section below. Don't forget to like, comment, and subscribe. And to watch more like this, click on the video shown on your screen right now. Thanks for watching. See you on the other side.